Okay, so let's go ahead and take a look at this next objective. So this next objective, what we're going to do is we're going to just work a little bit with some physics questions that you could possibly see on the actual AP test. Okay? And so we'll start out with this first example. A particle moves along the x-axis in such a way that its position at time t is given by that equation from -5 to +5. Determine the velocity and acceleration of the particle at time t. So velocity and acceleration of the particle, I want to take the derivative. So remember that the derivative of velocity is, the derivative of position is velocity and the derivative of velocity is acceleration. So v of t is equal to 12t cubed minus 16 times 3t squared plus 24 times 2t. Okay, so v of t is 12t cubed minus 48t squared plus 48t. So there's my velocity equation. My acceleration equation is take the derivative again. So you get 12 times 3t squared minus 48 times 2t, and then plus 48. So acceleration is 36t squared minus 96t and plus 48. Okay. At what values is the particle at rest? The particle is at rest when the velocity is equal to 0. Okay, so and that kind of makes sense. So the velocity being equal to 0, I'm going to take my velocity equation that I found in part A, and I'm going to go ahead and I'm going to set it equal to 0. So 0 is equal to 12t cubed minus 48t squared plus 48t. And then I'm going to factor out a 12t. So I'm left with t squared minus 4t and plus 4. So 0 is equal to 12t, and then this is t minus 2 and t minus 2 is what that factors to. So you get t is equal to 0 and 2 is when the particle is at rest. Okay? So now, when does the particle move to the right and when does the particle move to the left? The particle is moving to the right when the velocity is greater than 0. And then the particle is moving left when the velocity is less than 0. Okay, so we know from part B that when t is equal to 0 and 2, the particle is at rest. So in order to figure out whether the particle is moving to the right or to the left, we're going to do the chart, similar to the first derivative test. And then this will be sine of, instead of f prime, it'll be a v of t. And then your conclusion. And then you're going from -5 to 0, 0 to 2, and then 2 to 5. So then t is equal to -1, t is equal to 1, and t is equal to 3. Okay. We have defined t to be a negative value. So we could talk about time or the velocity or acceleration or the position of a particle before time is equal to 0. Okay. So sine of v of t, so v of -1 will be using my velocity equation, which my velocity equation is my factored form, 12t and t minus 2, the quantity squared. So v of -1 is less than 0, v of 1 is bigger than 0, and v of 3 is bigger than 0. So the particle moves left, particle moves right, and particle moves right. So the particle moves left on -5 to 0, and the particle moves right on 0 to 2 union 2 to 5. Okay? When does the particle, what value of t does the particle change direction? Changing direction means moving from left to right or from right to left. So from the chart, in part C, the particle changes direction from moving left to right at t is equal to 0. Okay? So all of these little parts that we're doing right now are possible questions that can show up on the free response test. So I'm trying to think of every single possible scenario that you could be asked with a physics question, and then trying to do it in this first example here. Okay, and so I have a lot of different questions here, mainly so that way I could try to get you guys to practice everything that you could possibly see. Okay, so part E, what is the velocity when the acceleration is first 0? So first I need to figure out when the acceleration is equal to 0. So my A of t is equal to 36t squared minus 96t plus 48 is equal to 0. Okay? And I can factor out, I'm sorry, not equal to 0 yet. I'm going to set it equal to 0, so 36t squared minus 96t plus 48. Now I can factor out a 12 out of here. So that gives me 3t squared, not cubed, squared, minus 8t plus 4 is equal to 0. I keep wanting to write equal to 0 on the right side. I apologize. So now 0 is equal to 12. I can factor this. This becomes 3t minus 2 and t minus 2. So then my t is equal to 2/3 and 2. Well, when's the first time that the velocity is or the acceleration is equal to 0? Is when t is equal to 2/3. And I want to know what my velocity is at that point. So I'm plugging in my 2/3 in for my velocity equation. Oops. And this is going to get really messy, but remember that when I plug in a value like this, I could also use synthetic division. So I could have done 2/3 and then done my coefficients 12, negative 48, positive 48, and 0. So copy down my 12. 2/3 times 12 is 8. Negative 48 plus 8 is negative 40. 2/3 times negative 40 is negative 80 over 3. 48 minus 80 over 3, you can find a common denominator. And once you find that common denominator, you'll get 64 over 3. And then 2/3 times 64 over 3 is 128 divided by 9. So remember that that remainder there is what v of 2/3 would be equal to. So that's 128 divided by 9. Okay? I could be asked to find the displacement over the given interval. And so Again, I'm going to be plugging in, displacement is the change in position, and so I'm going to be plugging in -5 and also 5 into my original equation. So remember, I can go x of -5 is equal to 3 times -5 to the 4th minus 16 times -5 cubed plus 24 times -5 squared. Or I could have done this with synthetic divisions. I could do -5, 3, -16, 24, 0, and 0. So bring down the 3. This gives me -15, so that's a -31. And then -5 times -31 is a positive 155. And then 155 and 24 make 179. And then -5 times 179 is -895. And then -895 times 5 is 4475. So now I'm going to do the exact same thing, but I'm going to do it with +5. So 3, -16, 24, 0, and 0. So I get 3, +15, -1, -5, 19. 5 times 19 is 95. So then 95, and then 5 times 95 is 475. So then my displacement is equal to x of 5 minus x of -5, which is 475 minus 4475, which equals -4,000. And that's my displacement. Okay? So my next part is going to ask you about maximum velocity. To find maximum velocity, anytime I want to maximize or minimize an equation, I need to take the derivative of that equation. So if I want to maximize position, then I take the derivative and I get velocity. If I'm maximizing velocity, then I need to take the derivative, which is technically the acceleration equation. So for my maximum velocity, I'm actually going to use my acceleration equation, and I'm going to set that equal to 0. So 0 is equal to 36t squared minus 96t and plus 48. So 0 is equal to, factor out the 12, 3t squared minus 8t plus 4. So 0 is equal to 12, 3t minus 2, and t minus 2. So t is 2/3 and 2, which is what we found in a previous example. To figure out which one is my maximum velocity, okay, what I need to do is I need to use my chart, okay? So I'm going to do my chart, and it's going to be with acceleration. So I'm going to go from -5 to 2/3, 2/3 to 2, and 2 to 5. Okay. So then what I want to do is I want to go ahead and pick my test values. So t is equal to 0, t is equal to 1, and t is equal to 3. So a of 0 is going to be bigger than 0, a of 1 will be less than 0, and a of 3 will be bigger than 0. So then my conclusion will be velocity is increasing. Velocity is decreasing. And velocity is increasing. Why is this important? Well, at this value of 2, I don't have to test to see whether or not it's a maximum because I'm going from decreasing to increasing, which is a minimum. So I really only need to check 2/3. So I find v of -5, and I find v of 5, and then I find v of 2/3. Okay, well, we found v of 2/3 from a previous example. It's from part E, and I got 128/9. Okay, now what I need to do is I need to find out what v of -5 is, and also what v of +5 is, which means that I need my velocity equation, so 12t cubed minus 48t squared plus 48. And then the same thing here. 12 times 5 cubed minus 48 times 5 squared plus 48 times 5. Again, you could use synthetic division, and it probably would be a little bit easier to use synthetic division. And so we'll go ahead and do that. So now when you do the synthetic division, so you would have had your -5, 12, -48, 48, and 0. So you bring down the 12, so then you get -60, so you get -108, so you get +540, so 588, and then -5 times 588 is -2940, so this is -2940. And then this guy, do the same thing, but do it with 5. 12, -48, 48, and 0. So you get 12, 60, 12, 60, 108, and 540. So this guy becomes 540. And the most positive number, which would give me my maximum velocity, will be when t is equal to 5. So what is the maximum velocity? Where should I put this? The maximum velocity is 540 when t is equal to 5. Okay? So now average velocity is the change in position divided by the change in time. So we know from part F that x of -5 is 4475 and x of 5 is 475. So average velocity is equal to x of 5 minus x of -5 divided by, 5 minus the -5. So I get 475 minus 4475 divided by 10. So I get 4,000 divided by 10, so I get 400. And that is my average velocity. What you notice is that none of these have units. None of the questions have units, or none of the parts have units, and so that's why we haven't put any units with any of these questions. Okay? So a common question is a question about speed. Remember, speed is velocity without direction. So we can define it as velocity without direction, or the absolute value of velocity, which also makes sense because it being negative gives it a direction, or it being positive gives it a direction. So speed is velocity without direction, so it is defined as the absolute value of velocity. Okay, so is the speed increasing or decreasing at this given time? I have this nifty little chart here. Yes, you do need to memorize it, but it's pretty easy. If your velocity and your acceleration are both bigger than 0, then the speed of the particle is increasing. If they're both negative, your speed is also increasing. If they are opposite sign, like here, then your speed is decreasing. Okay? So now, in order for me to figure out whether or not speed is increasing or decreasing, I have to figure out what my velocity and my acceleration is at time is equal to 3. So I need to find v of 3, and I need to find a of 3. Okay? To find v of t, or v of 3, I'm sorry, we are going to plug in 3 into our velocity equation. But I'm going to do it with synthetic division just because it's a little bit easier to keep all the arithmetic organized. So 12, 36, negative 12, negative 36, 12, 36, and 36. So v of 3 is 36. A of 3, so that is 36, negative 96, and 48. Bring down the 36. 3 times 36 is 108. 108 minus 96 is 12. 3 times 12 is 36. So I get 84. Both of them are bigger than 0, so the speed of the particle is increasing. So since v of 3 is equal to 36, which is greater than 0, and a of 3 is equal to 84, which is greater than 0, then the speed of the particle is increasing. Okay? So now, let's take a look at a couple more examples, or a few more examples. And you can use your graphing calculator for this. So let me be clear with the graphing calculator for something, for example 2, is I typically do all this stuff by hand, and then I just use the calculator to kind of evaluate. Most important thing when you guys look to evaluate with your graphing calculator, make sure that your calculator is in radians. So that means you do press the mode button and make sure that it is in radians, which you should have done for the previous units, but just in case, do go through and make sure that your calculator that you're using is in radians and not in degrees. Okay? So, example 2 here, find the acceleration of the particle at time is equal to 2 is the speed of the particle increasing at t is equal to 2. Okay, so first thing, let's find acceleration at time is equal to 2. Let's change colors slightly. So a of t is equal to product rule. Sine of t squared divided by 2. So the second term times by the derivative of the first, which is negative 1, plus the first term, which is negative t plus 1, times the derivative of the second term, which is cosine t squared over 2, times the derivative of t squared over 2, which is 2t over 2. So a of t is equal to negative sine t squared over 2 minus t, because that comes from this t over here, t times t plus 1, and then cosine of t squared over 2. And now what I'm going to do is I'm going to plug in 2 in for my t. So a of 2 is equal to negative sine 2 squared over 2 minus 2 times 2 plus 1 times cosine 2 squared over 2. And what you get when you use your calculator, and you can simplify this a little bit more if you wanted to, or you can go ahead and plug it into your calculator. Just be careful with your parentheses in order of operations. Okay? You should get that a of 2 is equal to 1.588. So a of 2 is bigger than 0. Now what about v of 2? Because remember, I have to use this chart up here to tell whether or not the speed of the particle is increasing or decreasing. So v of 2, negative 2 plus 1 sine of 2 squared over 2. So when you use your graphing calculator, you should get negative 2.728. So v of 2 is less than 0. So since a of 2 is equal to 1.588, which is bigger than 0, and v of 2 is equal to negative 2.728, which is less than 0, the speed of the particle is decreasing, because one of them is positive and one of them is negative. Okay? So now, let's look at another one. Changing the equation on you just a little bit, for example 3. Again, calculator is okay for these. It will indicate in your problem set whether or not the calculator is okay or not. Okay? So is the speed of the particle increasing or decreasing when time is equal to 5.5? Give a reason for your answer. So v of 5.5 is equal to 2 sine of e to the 5.5 divided by 4 and then plus 1. Remember, with your order of operations, you're probably going to have to put that 5.5 over 4 in a parentheses as well. So I probably would have done 5.5 divided by 4, then go e of the answer, then go sine of the answer, then multiply by 2, and then add by 1. Okay? So I should get v of 5.5 to be negative 0.453. And then let's do acceleration. So a of 5.5 is equal to 1/2 e to the 5.5 divided by 4. And then cosine e to the 5.5 divided by 4. And you should get that acceleration at 5.5 is equal to negative 1.359. And you could, because you're approximating it, you're rounding the decimal place, you could put approximation symbols. So since v of 5.5 is equal to negative 0.453, which is less than 0, and a of 5.5 is equal to negative 1.359, which is less than 0, then the speed of the particle is decreasing. I'm sorry, they're both negative, increasing. Since they're both negative, they're both increasing. Okay. Example 3 is in a different 3b is in a different form. So let's be clear. We talked about average velocity as a change in position over the change in time. Okay? I can define average velocity as finding the average value of the velocity equation. Okay? So what does that mean? So average velocity is equal to the change in position over the change in time. Change in time is from 6 to 0. Your change in position is defined by 0 to 6 of your v of t, which is 2e 2 sine e to the t over 4 plus 1 dt. So this first part, or the second part I should say, represents a change in position, and the first part represents a change in time. And this is the average value theorem that we talked about in a previous section. So I can then do my graphing calculator. And I get approximately 1.949. Now notice none of these had units attached to them in the directions, and so that's why there hasn't been any units associated with the problems. Okay. So the last question is finding the total distance traveled. Okay. Now there's two ways with finding the total distance traveled. There's the way with a calculator and one without a calculator. So without the calculator, remember that without a calculator, you have to see where the particle actually moves from the left to the right. Okay, so, and the reason why is because total distance traveled is different from displacement. Total distance traveled makes, when I move to the left, that be a positive distance for total distance traveled. Whereas for displacement, you count it as a negative. Okay, so total distance traveled basically takes the absolute value. Okay. So in order, without a calculator, for me to figure out where the particle is moving to the left so that I can make that distance a positive distance and not a negative distance, I would have to do the chart. So I would have had to take my velocity equation, set it equal to 0, and then solve. Now, obviously, I'm going to have to use a calculator for this. I get t is 5.196 in the interval. In the interval from 0 to 6, let's be clear. Because there is other places, but from 0 to 6, the time value is actually 5.196. And then I would have to do interval, test value, sine of b of t, and conclusion. And go from 0 to 5.196, and then go from 5.196 to 6. Pick a test value like 1, pick a test value like 5.5, and v of 1 is bigger than 0, and v of 5.5 is less than 0. So the particle moves right, and then the particle moves left. So that means that for total distance traveled without a calculator, this would be equal to 0, it's a very small 0, 0 to 5.196 of my velocity equation, 2 sine e to the t over 4 plus 1 dt. And then, there's a plus 1 there. And then, let me fix the plus 1. And then I would have to subtract off the distance from 5.196 to 6 of 2 sine e to the t over 4 plus 1 dt. And then when I do this, and I would have no choice but to use a calculator, but I'm just saying, if this shows up on the non-calculator portion, then this is the process you would have to do. You would get 12.573. Okay, so without a calculator, you have to set the velocity equal to 0 and solve, do the chart, and make the particle moving to the left negative, and then evaluate your answer. That's all without the calculator. Okay. With the calculator, total distance traveled is defined as the antiderivative of the absolute value of velocity. So that means 0 to 6, absolute value, 2 sine e to the t over 4 plus 1, and then dt. Okay, and then you still would get, when you do use your graphic calculator, you would get your 12.573. Okay, there is the absolute value spot. Easiest way to find absolute value on your graphing calculator is go to catalog, and then when you, it's like the first or the second one, and it's called ABS is your absolute value. Okay. Probably the fastest way to find absolute value is going to the catalog. There's a way to go math and hit a bunch of numbers, but I think catalog is a lot faster, and catalog is like right around where second and right around where the 0 and the decimal spot is on your graphing calculator. Okay? And that is it for this lesson.